I brought home this refrigerator and a washer and dryer, all for $500.
Here goes nothing. I'm going to clip the end off of that.
This could also be a wild goose chase. Here I am sitting kind of inside the freezer. That number is cause for concern. Good afternoon, I'm Dave, and this is Alaskan Homesteading. Today I have an appliance repair video for you. One of the ways that I like to save money as a homesteader is to not always buy brand new stuff. And so when I find a really good deal on Facebook Marketplace, typically, even if there's something slightly wrong, I'll pick it up. And today, well, yesterday was no exception. I brought home this refrigerator and a washer and dryer, all for $500. The refrigerator's issue is it is overcooling and needs, we believe, a new temperature sensor. The washer has no problems at all, at least none that I could find. The dryer, the seller told me, needs a new heating element. So we'll have a couple little repair videos out of this bargain hunting bonanza. But today I'm going to focus on the refrigerator. It is a GE, and we already have one GE refrigerator that I really like. It's a little smaller. This one is going to be the garage fridge. It's a pretty good size. It's like 36 inches wide, 70 inches tall, 36 inches deep. I think it's like 28 cubic feet or something like that. So it's a really good size. The temperature sensor we're going to be replacing is inside the freezer compartment. You can see that little doodad down there on the side. And we believe that it's the temperature sensor down here because the freezer was reading like 33 degrees, even though it was obviously quite a bit colder. The gentleman that sold me the machine had it up and running in the garage at his place just so that I could observe that it was actually functioning at a basic level. He was upfront about all the different repairs he'd already done as far as replacing some fans and an air valve and some other things. So fridge freezer like this is normally about $3,000, maybe a little more, and for me to pick it up along with the washer and dryer for $500 is really outstanding. Well, anyway, let's get started. I'm going to figure out how to get in here and take that little sensor cover out, and we'll go from there. So what I think is it's probably just a little clip that snaps to the side to pop it out. I couldn't find any videos on this one. There's a lot of videos on refrigerator and freezer repairs, but I couldn't find one on this machine. There we go. Okay. Pops out. We've got just a little bit of extra cord. A little bit of insulation on there. That piece is already... Okay. That's just kind of covered over with a piece of foil. Get that out of the way. And this has a little blue tag on it. Well, let's take a look at the pile of sensors that the guy gave me. So he had already ordered a bunch of parts. I guess he had wanted to keep using the fridge, and he seemed like a fairly handy fellow. So he gave me this 5-pack of sensors, and then this one I think might be either sensor or, from the look of it, maybe a heating element for the defrost. I'm not sure about that. We'll set that aside. But these are all temperature sensors, just thermistors, and simple 2-wire hookup. No polarity. The way these work is that they register a particular resistance in response to a particular temperature. And so the machine knows what the resistance and temperature curve is of these thermistors and is calibrated to it. So you just cut the old one out, put the new one in, and in theory, that should be it. I guess we'll see. Some minor electronics knowledge is handy. I think, and this is speculation, educated speculation I'll call it, I think that the thermistor in the freezer compartment is a 5K thermistor. Here's an example chart, and this is not for that particular thermistor, but it's a thermistor chart that shows you temperature in either Celsius or Fahrenheit along the left side, and then for different ratings of thermistor, in this case, here's a 5K, a 10K, etc. It'll give you what the temperature should be at that point in its curve. And so you'll see 25 degrees or 77 degrees Fahrenheit for 3,000 ohms, 5,000 ohms, as in 3K, 5K, and then 10K, and so on. And so I have a multimeter here that has its own thermistor probe, and it will read in degrees Fahrenheit. I think I can switch it to degrees Celsius somehow, one of these buttons. I'm not sure. This is a feature of this multimeter that I don't use very much. But it says it's 52 degrees Fahrenheit in here. So as an approximation, I'm going to say that if we can read the resistance of one of these thermistors and see if it's close to what the reading should be for a 5K resistor at 52 degrees, which in this case, again, this is not for this specific thermistor, but it might be good enough for an approximation. So 50 degrees Fahrenheit on a 5K, 9,041 ohms. Let's see if we're even in the ballpark. I'm curious. This could also be a wild goose chase. 6.67 on a 20K scale. Okay, so 6,600, 6,600 for 50-something degrees. That's definitely very different from the other one. Again, I don't have a spec sheet for these. These are something the guy handed me that he said, "Oh, I ordered these for the refrigerator, but I just didn't get to it." Okay. So we'll see. I wonder if that 6,000 would correspond to something on a different thermistor scale. So 6,000, if this was a 3K, where would that put us? That would put us right around there, 5969, 6,000 for 50 degrees, and a little bit higher for a lower temperature, a little bit lower for a higher temperature. So, but we are right around 52 degrees according to my other meter. And the packaging these came in, X003AIU30X. I might suspect that this is a 3K, just based on that. Again, very much guesswork here. What if we look up that part? X003AIU30X. That didn't come up with anything. Let's try a 0X just in case. No. How about AC-001-5 sensor? That doesn't look like it. Of course, I don't even know that this is the bag that those things actually came in, so this could be another completely wild goose chase. So the next thing for me to do is to take another look at that sensor inside the fridge and see if it has any more clues for us. 211013 EPCOS 5K A403 0532. And so I would bet that 5K means this is a 5K thermistor. So I'm not confident that those replacement parts that the guy provided are going to be the right part for this. So I've got the thermistor for the refrigerator in my hand, right next to the thermistor probe for my multimeter. So I'm measuring temperature on the right side meter. It says 79 degrees Fahrenheit, and there in my hot little hand. And then we're getting about a 4K ohm reading on the thermistor for the fridge. So is there a corresponding reading if we say, about 80 degrees? 77 would be 5K ohm for a 5K or 3K ohm for a 3K, and 86 would be 2417 on a 3K or 4139 on a 5K. We're at lower resistance is a higher temperature. So if we're at 3.8, then we're maybe somewhere. See, I don't like this. I just wish that I could have the proper sensor reference for this particular thermistor, because this could be way off, but this could be really misleading. But if we're between 77 and 86, so 83, 4K ohm would be reasonable for a 5K resistor at somewhere in that 80 degree range. I'm just not sure what to make of this. Either way, I know that sensor inside I strongly suspect that sensor inside the freezer is defective, because when the freezer was running, it was reading 33 degrees, and it was quite a bit colder than that. Let's take a reading off a different copy of the same thermistor from that bag. So that's 6.5, 6.6, just sitting here ambient. And these ones I haven't touched. They've been sitting over to the side. This one's at 6.5. Okay. So I believe these two are at least the same. And none of them have any writing on them or anything, so there's really no telling. And that's 6.6. So I'll say that's also the same. Because these should all be pretty well stabilized at the same temperature here. And that's 6.6. So yeah, those are all the same. Has this one come back down in temperature yet? Because I put a fair bit of heat into its little case. That one's at 4.8, so it's still warmer than ambient just from me holding it for a while. I can even feel it just touching the plastic. I can feel that this is warmer. Well, the next thing is to cut the one out of the freezer. No going back after that.
Here goes nothing. I'm going to clip the end off of that, give myself a little bit of lead so I can just take some measurements off the theoretically bad thermistor. Yeah. It's cut off, and we'll see what it reads at ambient temperature here.
Well, let's see what that reads. That's reading 4K. Let's let it sit and cool off. I've been handling it. Now that one, at least there were some manufacturer markings. Epcos is definitely a manufacturer name. See, we've got this 211013 Epcos 5K A4030532. That's what's on the wire. And if it is a 5K and we're reading 4600, that should be, yeah, that might be reading high. Again, I couldn't find the data sheet for this part either.
Okay. One lead there. One lead there. Onto the leads for this other replacement thermistor. And now we've got this guy hooked up in place of the original one. We can stick that somewhere out of the way. Just put it right there in the side. It doesn't want to stay. Just do that. And then this way I can power the machine up and see what happens, see what kind of readings we get.
Well, we've got our booting logo, and now we're up to a menu, and water system is off. Okay, settings, photos, slideshow, water filter. I mean, this thing's got a USB port. Let's see here. Ice maker off, door alarm off, sound low, cooling system off, temperature, Fahrenheit, dispenser, milliliters. That's incongruous. Imperial metric. Why? Autofill video tutorial. Okay, I don't need a video tutorial right now, but I do need to turn on the cooling system. Yes. Done. And then we wait. So the default settings, 0 for the freezer, 37 for the refrigerator. And if we go to that, it's saying actual 0 on the refrigerator. That's not believable, obviously. And on the freezer side, actual 0, recommended 0. Well, we're going to change that. We're going to put it to -5 on the freezer. And the refrigerator, it's recommended 37. We're going to set it at 42. A very special number. And then we'll wait, and we'll see what happens in a little while, see if it starts reading some actual temperatures inside there. So, more research, and I found how to get into the service mode. One thing that was interesting was the machine seemed to be not done kind of stabilizing, because it was saying actual 0, recommended 38, and now it's saying numbers there. It's saying, actual 41. Okay, fine. And then if we go to temperature for freezer, it's saying actual 58, recommended 0. So that's interesting. I didn't realize that it took a while for the thing to stabilize, and I was in this service menu for a while, which you get into on this machine by holding down all 3 of these buttons on the dispenser, water crushed and cubed, and hit yes, enter service mode. Oops, didn't get there in time. Try it again. Yes, service mode. And once you're in service mode, you can select different settings. So 26, that's one of the thermistors for the fresh food compartment. It thinks it's 8 Fahrenheit, which is absolutely not true. And this one thinks it's 71. So that's this is the freezer thermistor that I just held in my hand to warm up. So that one I know that I just replaced unnecessarily, probably unnecessarily, is functional. So if you go back down to like 24, 35F, that's certainly not true. I think that's the fresh food compartment sensor number. And so you have to kind of look up for your model of fridge the different test numbers. In this one, fresh food 1 thermistor is 24, and fresh food evaporator thermistor is 26. So if we go back, so that was 24 was that the fresh food compartment test, and then 26 is going to be that evaporator temperature test. And that says 12.8. I'm skeptical. Maybe that's possible. You know, that's a thermistor that's clipped onto the evaporator line. So if this thing is cooling, I know it's cooling because I can tell. I put my hand in there and it's cooler than it was. What I'm suspecting now is that the fresh food compartment sensor reading 34F is just wrong. So I am going to pop that one out, clip it, and see what kind of readings that thermistor gives us, and hook up one of the replacement thermistors to it and see what kind of a reading it gives us. If we go back to the freezer compartment thermistor, that's freezer thermistor test 27. Oops. That's reading 70, which is that one that I had my hand on. And if we want to look at the freezer evaporator thermistor, number 28, that one's reading 42.9. I'm not sure about that. I'm just not sure about that. That one I'm skeptical of as well. So that one is a thermistor that is clipped to the evaporator line inside the back of the unit. So we're going to exit service mode, turn off the machine, and clip the thermistor. Actually, yeah, no. We're going to go in here and do open heart surgery while the patient is alive and figure out how to get this piece unclipped. Okay, there we go. Same as the freezer unit. Well, I'm at a bit of a loss here because now I have operated the machine for a bit, gotten into this test mode, and now I think I'm getting believable values from these components in this thermistor test mode. Freezer thermistor, freezer evaporator thermistor, number 28. Let's check that guy again. It says 39.6. So that's saying that the freezer thermistor is high. But if we go back to the freezer compartment, what do we get? That's number 27. 6471. So that's the thermistor that I just installed. I'm going to have to think about this for a little bit. Maybe let the fridge sit here and finish kind of stabilizing and go to temperature. See what these values look like later. Let's see. Hopefully that freezer evaporator temperature will get much lower. if it doesn't, maybe that freezer evaporator thermistor is our issue. I wonder, because that's clipped to, or is supposed to be clipped to, that's supposed to be clipped to the evaporator line. If it's not, then it's going to think that the evaporator isn't getting cold. I'm going to have to open up that compartment and see if that thing's clipped in there. This refrigerator, according to the previous owner, has been moved several times. He's former military, and he's had several PCSs, permanent changes of station, and gone, all across the country a bunch, including, down to the lower 48 in Alaska and so on. So it's entirely possible, in my mind, that thermistor on the freezer evaporator could have been unclipped just through jostling. So I think that's going to be my next look at, is getting into that compartment in the back of the freezer and seeing if that freezer evaporator thermistor is where it's supposed to be. After my diagnostics here, what I'm thinking is that the thermistor that is supposed to be attached to the evaporator coil in the freezer compartment is not connected, either not connected or not reading correctly or something like that. And so I need to remove this panel to locate that thermistor and make sure that it's proper. So a couple of 1/4 inch nuts to drive out. Clip here. That has to come out. Arm. And then this. Move this panel, but maybe not. Rotate that. Okay. And then disconnect the leads. Okay. All right. So this is the evaporator. There's our thermistor, and it plugs into this little connector back here. We're definitely getting some ice on there, so it's cooling. It's definitely making the cold. But I wonder if this thermistor is not performing correctly. It's clipped where it's supposed to be. It's on there, but I don't think it's giving a valid value. That's my unprofessional opinion. As I mentioned, it's really a good thing I'm not a much bigger person, because here I am sitting kind of inside the freezer. Getting in and out of here is a trick, but not bad. That's a little spot to get into. Well, folks, I think I may have found the problem. You see where that thermistor is, that white knob of plastic? Right there, clipped onto that part of the evaporator line. Well, when I look in the service manual, you can see that it is clearly clipped on the other line. And that matters, because the right side of that is getting cold and has ice crystals forming on it. The other one is not. And so what I think is that the previous owner of this fridge may have replaced this fan assembly along with that thermistor and clipped it onto the wrong spot. And that's why this thing is not it's overcooling because it thinks that the evaporator isn't getting cold enough. So I think I'm going to clip that thermistor onto the other side, close things up, let it stabilize, and see how things look in a couple of hours. But first, I have to melt the ice off of it so that I can get the clip around it. Okay, now we can clip that onto the correct side. And we'll get proper readings for the freezer evaporator. And then I'm going to have to repair this, put that back together, because that was not the correct thing to cut. But not a big deal. It's easy enough to splice back together. The lesson learned, though, on that is do your own diagnostics first. After moving the side of the evaporator coil for a while so that I could do some other work, the temperature numbers change. Well, as we can see, we're getting a much more reasonable reading from the freezer condenser thermistor. Let's go and take a look at the freezer compartment thermistor. 34, okay. What does the thermometer I put in there say? That says 41 down on the floor in there. I can put that over here near the thermistor and see if it gets a different reading. And then how about the refrigerator compartment? 36.4. And the refrigerator condenser thermistor, 30.31. And if we look at this gauge, this thermistor says 36. Entirely all plausible readings. Let's see, meat, beverage, produce, cheese, citrus. Let's put that on citrus. Put this down in here and see what kind of reading it comes up with later. Let's find the code for the deli pan thermistor. That's 30. It says 36.4, and that agreed with, or close enough to, the fresh food compartment thermistor, number 24. I think we're in pretty good shape here, but we'll let this run a while and see what it says. That number is cause for concern. The freezer condenser thermistor is certainly not 654 degrees. It just went down to 0, and as soon as it went below 0, presumably it was in that trajectory, it went to like 655, and now it's going in this direction, which is very, very strange. It took me a moment, but I realized, I think, that the number that we're dealing with is a little bit special. It was at 655 point something degrees, 655 something something. And what occurred to me was that that is like an overflow in an unsigned integer value in programming. We went from 0 and went negative, and were unsigned, so it wrapped around to its highest value. hopefully that's just a display defect and not a algorithm defect inside the coding that tells the thermostat what to do. Because if it really thinks it's 651 degrees in there and doesn't understand that that's, -4 or something, then weird behaviors will be exhibited. All right, I'm back from dinner and I'm checking on the fridge, which has been reassembled and stabilizing for a while now. Let's take a look and see how it's performing. The test display is still showing the incorrect value for the freezer condenser thermistor. But what's happened here is the programmers who implemented this display used the wrong value type. This is an unsigned 16-bit integer value. Why do I know that? Well, because I was a programmer for 20-something years. So what happened? When it got down to 0 and then went negative, less than 0, the unsigned integer 16-bit size wrapped around to its maximum value of 65535. And so now we're at actually minus something, so 655.35 minus 651.28, you do the math, and that'll give you the actual negative, the temperature in negative degrees Fahrenheit. So just a little side trip there, just for S&Gs, for folks who understand programming. But the point is, the error that I found in reassembly was in fact the problem. If we go back and we change to monitor the freezer compartment thermistor, we can see we're back down to like 17 degrees. I had the thing open for a while I was doing final reassembly, putting all the stuff back in, the panels and reconnecting the thermistor and all that stuff. So this thing is working great. The fridge itself is pretty neat. Go over a couple of the features. It's got this separate little crisper drawer with its own independent temperature setting. So it's got its own thermistor to monitor that drawer, and it's got a little circulator fan in the back, way back in there, that helps it move the colder or warmer air in to make this colder or warmer than the ambient temperature in the main refrigerator compartment. Ice maker thing in the door, just like the other GE fridge I've got. And then freezer, it's got a couple of nice drawers, and we're reading 13.3 degrees on that one and 16.7 on the test display. That's, I guess, within what I'll consider a reasonable margin of error, two different types of sensors. But I picked this refrigerator up on Facebook Marketplace for $300. And the reason the guy was getting rid of it was, A, he didn't have a lot of space for it anymore. He'd moved to a different home. And B, the thing kept freezing stuff where it wasn't supposed to freeze it in that crisper drawer inside the refrigerator compartment. It was getting too cold. And the reason why was that subtle error that was happening with the placement of the freezer condenser thermistor. It was on the wrong side, as I showed in a different piece of video, and that was causing the algorithm, the control circuitry inside this system to think, well, the condenser's not getting cold enough. I need to run this longer to get the freezer colder. Meanwhile, the freezer's getting colder and colder, but the condenser is actually at the right temperature and all that. So kind of an interesting bug in the logic that gets triggered by the defect in the assembly. But that's going to be pretty much it for this little project. I'm super happy with how this turned out. Well, that's going to wrap it up for my homestead refrigerator repair. Got a screaming deal on Facebook Marketplace. Had to do a very, very minor repair, if you could even call it that. It's more of an adjustment to a component assembly. And that was it. So thanks so much for watching. If you want to keep following along when I do these kinds of projects, I've got a playlist called Fixin' Stuff that you can follow. And that's where I do these kinds of projects, where I just do random weird repairs on things. If you want to see more content from me in general, go ahead and subscribe. Like this video if you thought it was good, and we'll see you next time.